Understanding and configuring Cisco rep. A friend and I were just having coffee this morning, and we were talking about this Amazon Prime Air concept. It's a beta that Amazon is trying right now, where when you buy something online at Amazon, they put it in these little yellow boxes and fly it to your house within the metropolitan area. You see my Metro E tie-in, right? Within the metropolitan area, within 30 minutes of it leaving the warehouse, it's sitting there on your doorstep. So essentially, it's virtually instantaneous delivery when you order a product. And this friend of mine, he looked at me, he goes, I can't people just be content waiting a day for normal Amazon Prime shipping? And I said, are you kidding me? If they roll this out in my area, I'm going to be buying stuff all the time. I'd be like, kids, you need markers. Let's buy it. We'd all run out in the lawn and be cheering the drone. Come, drone, come. Hands raised and all that as it delivers this. Although I would be one of those people, because I'm wondering, watching this drop off at the doorstep here, what's to keep somebody from grabbing the drone? I'd be like, kids, get the drone. We'd all, come and tackle it and, dismantle it to try and figure out how this thing works and all that. Anyway, I digress, right? Cisco rep, and here's this whole tie-in, Metropolitan Ethernet, need for speed. That's what it's all about. So in this nugget, we're going to talk about what is Cisco rep, what is the key features of it, and then how do you set it up on Cisco Metro E switches. Well, let's start off with the premise of Cisco rep. First off, why not start right there? Cisco rep. It is Cisco proprietary. Cisco Resilient Ethernet Protocol works on Cisco devices as an alternative, and I'm using my words very carefully right now, an alternative to Spanning Tree Protocol. Spanning Tree Protocol being awesome, designed back in the foundations of networking. People wanted redundancy, but they found out redundancy blows up their network in a layer 2 situation because of looping broadcasts. So Spanning Tree back then, with a 30 to 50 second convergence time, solved the need because back then people played outside in grass and with balls and things instead of staring at screens all day, where we had this mission critical environment. Well, as time went on outside, who wants to go out there? We stare at screens, and now we need this instantaneous kind of availability. And so about 2006 timeframe, Rapid Spanning Tree came along to improve things. Took that 30 to 50 I keep saying millisecond because that's the way we think nowadays, but second convergence time of Spanning Tree and brought it down to 2 to 3 seconds, which is awesome. Can I emphasize, wow, that's amazing, but still considered slow for our triple play environments. Now, that may be the first time in this series I'm using the term triple play. A lot of carriers use that to describe the voice, video, and internet kind of cocktail that we send across the links to business and home environments as triple play. So 2 to 3 seconds means, interruptions of service on television programs. It cuts out completely. Voice over IP, if that isn't in use, is being dropped on calls dropping, all that kind of stuff. So we have to have a way to lower that, and Cisco rep is the answer. You might have read ahead. It is designed by Cisco around a 50 millisecond convergence time. That's best case scenario where the switches detect a loss of signal, meaning a cable is cut and it can tell that signal has been lost, which is most cases. Or 250 milliseconds worse, that's if it maybe the signal stays up and we have to rely on hello timers or some kind of other detection mechanism to fail over. Now, before you're like, well, Spanning Tree is out and rep is in, this is not what Cisco is designing rep for. Rep has a very specific circumstance that it's created for, and its mission, if you looked at its resume, is to handle those sonnet rings. Right? That is its goal, because the beauty of Spanning Tree is its plug and playness, right? You go figure out where the root bridge is going to be, click, 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 click. We plug in all the links and Spanning Tree figures it out. It says, okay, what's the best way to the root bridge, and then block the redundancy, right? We know how Spanning Tree works. Well, Cisco rep is not out on a mission to replace Spanning Tree, but to squish it into its rightful place, the core. Put it back in the core of the service provider or in the enterprise of the customer. Spanning Tree works well. However, we will, so let's just say this is our sonnet ring essentially running around a city or something like that. And then over here we branch off into a POP, to where inside of here we have our redundant connections and, core switches, all of the stuff we've been talking about in this series. Sure, go ahead and run Spanning Tree or some other protocol inside of there. And when I say Spanning Tree, I'm talking Rapid Spanning Tree, right? Nobody should be using Spanning Tree in any kind of mission critical environment at all anymore. But rep can give you that crazy fast failover on the Metro side. So this is designed for the Metro Ethernet switches. You must be running one of these iOS images, Metro Access or Metro IP Access, to use it. Well, let's now dig deeper into rep, and you'll understand quickly why spanning tree is not going away anytime soon. First off, in the rep environment, you identify your segment. Now, what does that mean? Segment means group of redundant ports that are linked together. So looking at this is a typical diagram of a sonnet ring, right? Is this redundant? Yes. Because if we have a broadcast, let's just say there's a device here that sends a broadcast, it will loop out this direction and go around and take down the entire network. But let's spin it from a positive perspective. That means if let's just say we're accessing a resource over here and this link goes down, well, we can go back around this way and access that same resource. It's a redundant design. So this is what defines the segment. And you and I, this is a very manual process, go into the segment and identify the edge ports. Essentially, where does the segment begin and where does it end? Now, in this case, I have them identified on the same switch, but you don't have to do that. You could have an environment go like a big chain, right? Something like this, where we say this is edge port 1 and this is edge port 2. We're identifying essentially the head and the tail of the redundant configuration, and everything along the way is manually configured. Each port is configured as part of that rep segment, and if you misconfigure it, you could very easily cause a loop. Rep is very dependent on you and I doing our jobs right, having the diagram in front of us, identifying each port as we're configuring it, because if there's one misstep, you can, I would say, worst case, cause a loop that takes everything down. Best case, cause a block that essentially cuts off your segment. We'll talk more about that in just a second. So we configure it. All ports have to be manually configured, no plug and play. The mission of rep is that the two edge ports will never see each other. So we've got edge port 1 and edge port 2. They're looking this direction, right? And they should never see each other. So it's going to identify, based on a port priority, very similar to spanning tree, where it's going to put a block in place. So let's just say these switches block this segment right here, right? So block is in place. These switches end up going this way to access their resources. These switches end up going this way to access their resources. Now, let's say that we have a disaster, a tractor comes in. My son would have a heyday with this right now. You know, comes in with its little backhoe, chop, and cuts that segment in half. We now have a break in the line, and it's going to say, okay, there's either a loss of signal or a loss of rep adjacency, because these guys form adjacency. I'm going to immediately send a multicast notification, and that shoots out this direction, which essentially says remove all blocks. Essentially, we have a break in the line, all blocks are now removed, and clear the switch MAC address table. So as this multicast, which is processed in the hardware, it's how it happens so fast, runs through all of these different devices. They automatically clear their MAC address table and remove any blocks that would be in place. And I ironically had my little backhoe of death, and blood dripping, come and cut the segment that was blocked. But we could very well drive that over here or drive that backhoe over here. Essentially, wherever it comes and cuts that connection, the multicast will go out, and this block would have been removed in that case, allowing everything to start running and relearning the MAC address table. So if this guy was previously going this direction, maybe now it's going this direction and has to repopulate its MAC address, which it does very quickly. Now, last note that I'll put in here, spanning tree and rep can coexist, however, never on the same port. And we'll talk more about this in an upcoming slide. They can actually even interoperate, and I'll use that word very loosely right now, to where, let's say, this feeds into the POP of a service rider. Here's your link in to the sonnet ring, and that inside of there has multiple, we'll say, distribution switches coming down to multiple access layer switches. You could have, spanning tree running all day in there and rep running all the way over here. And it can even say, okay, if there's a block, a break over here, I can send that into the spanning tree network and allow them to react based on that break, so they can have some kind of translation between them. That's a better word to use. However, they never can exist on the same port. This cannot run rep and spanning tree at the same time. Before we get into the configuration, last few key items on rep. Number one, Cisco rep can support more complex topologies. My pen's running out of ink. This is funny. I I don't know what to do about that. So I guess we'll just have some very faded pens on this slide. So Cisco Rep can support more complex topologies. So rings connected to rings, so you could have a whole devices something like this. Right, if we can all see this, and then this going to another ring down here. You just again have to be very careful in your configuration because you can have rep misconfigured and it can easily cause a loop that can cause some disasters. Failure in rep is detected through a loss of signal or a loss of neighbor, meaning the hello messages between they have hellos, they have relationships between each other go down, and that really depends on your convergence time. Loss of signal gives you a super fast 50 milliseconds. Loss of neighbor is typically 250 milliseconds, but either one much faster than rapid spanning tree. Failure notification is sent with a multicast with an acknowledgement, so you know that everybody got the multicast message and they react immediately. Preemption is supported in the rep world. So let's say we had our original block put in place here, but we had a break in the line over here. By default, it will remove the block, and then this will be the new block once it comes back up and we repair the physical damage, we'll say, to the line. Or we can go preempt to where we will always know where the blocks are. So once this is repaired, it can go back to blocking the original state. Right? It is secure, meaning when rep comes online, all these different switches negotiate essentially it's a hash, a key that allows them and only them to remove the block. Otherwise, we could be sabotaged where maybe a customer sends in a rep message that says, hey, remove the block, and that ends up causing a loop in our environment because it was an unauthorized block removal, right? So all the rep neighbors that you configure negotiate a key, and only those neighbors can remove the block. No one else is allowed. Rep, and this is, let me actually scribble this out. It doesn't speak the spanning tree language. It can translate. I came up with that on the last slide. Translate the spanning tree language. It integrates in between the two using topology change notification. So this is the language of spanning tree protocol, right? So let's just say you've got rep running on these rings, these faded rings down here, and then this feeds into your larger network down here, which has that redundancy, access, distribution, core kind of feel and design to it. Well, when a rep failure occurs, you can actually have this switch act as a translator that says, okay, I'm going to take that rep failure and translate it in as a topology change notification, which is what Rapid Spanning Tree uses to update everybody on maybe a link down or something like that. So maybe these guys have a connection over to another sonnet ring, and they can start using that one instead of the first one because maybe it's more efficient, right? So again, big picture planning is needed for this. Lastly, it does support load balancing. So we can have, just like multiple spanning tree protocol, a whole bunch of VLANs going one direction and a whole bunch of VLANs going another direction. So we're using our sonnet ring efficiently, and we don't just have idle fiber sitting there. Now we get into the configuration. Number one rule is to start with one port and work your way down the chain, or what I would call the rep segment. Now, let me even step back before this. This is something you either A, do initially when you're setting up this new sonnet ring, or B, you have an outage window scheduled to convert from rapid spanning tree into the rep configuration, because it is service impacting. So we've got this chain of switches. Let's say that you and I are sitting over here. This means that we would SSH into this device and set it up with the rep edge port on this side, and then configure link by link. This one, this one, this one, this one. This is the work your way down the chain, all the way down to here where we configure the final edge port to the device, and then rep would step in and put its block in to say, okay, well, we'll block the redundancy like that. Now, keep in mind, I'm showing you a chain of switches, but I want to make sure that we catch, what is this chain of switches? Big picture, this is connected in to some other larger carrier network. Let's say that we have our carrier core right here with, our two giant, we'll say CRS 3 switches right here that are connecting to this big sonnet ring. So this is that chain that I'm drawing right here, right? So what I'm doing is kind of surgically taking this little chain right here out and putting in here, but it is connected to the bigger network up here. So when you're going, well, why would you block that? Well, it's because that we have this big loop. It's a sonnet ring of redundancy. So this would be the same thing as me drawing a line right here on that. So these switches go this direction to reach the core. These switches go this direction to reach the core, we'll just say core service provider network, right? So does that help kind of put that in perspective? Okay, so let's say we're sitting right here. This is putting our place in the picture. translating this into the bigger scenario, that's how we would configure it. Now, rep ports are always layer 2. They are trunk ports. They are not layer 3 interfaces. They don't bridge into a switch virtual interface, nothing like that. This is just pure layer 2, and they all have the same VLANs assigned to them. Now, that's not a requirement for rep. It's not like rep will say, whoa, I can't do this because you don't have the same VLANs, but it will cause a whole lot of chaos because you have an inconsistent configuration. Only one per segment. You'll either use rep on an interface, spanning tree on an interface, or flex links on an interface. You may not have heard of flex links before. It is another Cisco proprietary deal, which is local. It is sweet, actually. If you've got, let's just say, a redundant configuration, a little ether channel going on, and we've got this switch who has a connection here and a connection here, you don't want to run spanning tree because it is, too much configuration, too much to think about, too inefficient, whatever the case is. You can set this up as a simple flex link where I go in and say, this is my primary, this is my backup, and all that happens is it essentially watches the Cisco switch locally right here. This guy watches, he's looking the wrong direction. He watches the link right here to see if it's going to go down, and if it does, again, loss of signal, it immediately brings up this backup link. It is a quick, dirty, simple replacement for rep or spanning tree. Actually works quite well in data centers, carrier facilities. Anyway, you're only using one of those, right? They are mutually exclusive features. Now, rep default state is to block unless you are told to unblock. And this goes right back to why I'm giving you this advice from the beginning, to start over here and work your way down. Because as soon as you configure this switch, let's say we're sitting over here and we turn this on for rep over here, this shunk goes into a blocking state until it can negotiate with the other side. Once it does, it says, okay, I'm going to come up. So you can see my little guy. I was just thinking, you ever been in one of those situations where you're configuring a device and you hit the enter key and your telnet prompt or your SSH prompt does not come back? I was like, what visual would just encompass that? And the only thing I could think of was dope, in Simpsons. And so that picture of Homer I've had that look so many times. If you've never cut yourself off from a switch remotely before, your time is coming. It will happen. I'm not speaking negatively. I'm just saying, I'm sorry, bro. It's going to happen at some point in your life, and it's just a bad day. So you want to make sure that you know that this default state is blocked. So work your way down the chain. So by the time you get here, all these links are going active, 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 and then we regain connectivity to the whole chain. Okay. On Metro Ethernet 3400, which is the focus of the SPNGN2 series, I'm talking certification-wise, only NNI ports can run rep, not UNI and ENI, and that makes sense. I mean, these are user-facing ports, not the network-facing ports, which is, this is all a network-based feature. I'm going to switch headsets so I can be closer to my Metro Ethernet switch. Well, let's take a look at the configuration now of rep. There's actually not too much to it, as you can see on the screen. First off, identifying the device that I'm on. I'm sitting here on a Metro Ethernet 3400 24TS, which, let me just bring this up in, eBay. This is what it looks like. Essentially 24 fast Ethernet Metro E ports that would connect to end customers. Over here, and by the way, these are all UNI ports by default, right? These guys are the NNI. Those are the gigabit uplinks that would connect up to the service provider network, right? So that's going to be what we're looking at. Now over here on the screen, let me just hide this for a moment. You can see that number one, we're going to identify which interface we're going to configure as rep. Now this is administratively, like we look at the switch and we go, that's the guy, he's going to be configured as rep. If necessary, configure the port as an NNI port, and I'll show you the running config of the switch in a moment, so we can verify that. If necessary, configure the port as a trunk. You'll see here that if you try to configure a rep port on a non-trunk port, it'll actually give you an error message. And then you configure essentially it's one command to turn rep on to say you are a part of this segment, and that segment number has to match on all the ports that are going to join that same segment, as well as I was trying to think, edge status would probably be better. I was just thinking edgeness, right? It's got to know whether it's the edge port or not. So let's bring that switch, not that one. Bring that switch up in the configuration. I just cleared the configuration and booted it up, so we are on a brand new, fresh switch. There we go.
Get into global config, get past all of these. Well, actually, before we go into global, let's just do a quick show run. Now, I think this is the first time I've gone to the, let me just get a clean view there. Gone to the command line of one of our Metro Ethernet switches. You can see that this switch, by default, we've got fast Ethernet 0/1 shutdown. Just by design, out of the box, all of the Metro Ethernet UNI ports are shut down. Notice the gigabit Ethernet 0/1 is the one that is an NNI port, and it is not shut down. That's over there on the right-hand side of the switch, right? So why don't we just hop under there? So we'll identify. Now, if we wanted to, we could go under fast Ethernet 0/1 and do a port type, and you can choose whether it's UNI, ENI, or NNI. So we would just go in and set that port type to NNI, and it would be able to be configured for rep. It would not if it was UNI or ENI. So we're not going to do fast Ethernet 0/1. We're going to go under gigabit 0/1, and the command that you're going to type in is rep followed by the segment ID, and you choose the segment ID. Now this has to agree the entire chain down, right? So I'll just grab 50. Why not? So segment ID 50. If you're configuring a normal port, meaning this guy, etc., then you just hit the enter key, and that will now allow him to participate in the rep segment. Let me hide this. Oh, that didn't work well. There we go. If you're configuring the edge port over here, then you'll identify it as the edge. Now, when you're configuring edge ports, essentially you'll have one primary edge port and one, we'll just call it a secondary edge port or backup. Essentially, someone has to say, I'm the head and I'm the tail. I'm the front and I'm the end of this segment. Now, if you configure both of these as primary, it's not going to explode. It's just going to say, okay, well, it looks like we have a tie. I'm going to use the port priority to break the tie. One of them will become the primary. So better off knowing where it is. So let me hit the up arrow rep segment 50, and I'll just say edge followed by primary. Now watch what's going to happen. Enter. It says, sorry, command rejected, conflict with the current switch port mode. And why is that? It's because it's not a trunk port by default. So I'm going to type in switch port mode trunk, followed by, hit the up arrow and say edge primary, and there we go. Notice it says, warning, this automatically disables spanning tree protocol in this port. It's recommended to shut down all interface, not currently, to essentially, warning. It's some kind of thing. Remember the old days of configuring port fast? If you've been doing Cisco for a while, they used to have a big old paragraph message that would come up and say, port fast warning, you could cause temporary switch loops because you're essentially disabling spanning tree on this port. So that's it. I know it's kind of like all of this concepts up to that. That's it. But the key is, again, to identify each of the ports in the chain. This one would be the edge primary. Then this would just join the segment, kind of work your way down until you reach the other side. Now, I only have one Metro Ethernet switch, but normally in a full-blown service provider network, you would have a chain of them going, one to another, or moving from, the ME3400 up to a CRS1 or whatever you're connecting to on the other side, and you could do the show rep topology, and that would actually show all of the different ports in the chain. Now this one's coming up and just saying, hey, we've got this switch. Its role is on gig 0/1. It's in a state of fail, essentially because it hasn't found any other rep neighbors on the other side. So rep is not currently working on this switch. Hopefully that gives you the idea and the place of Cisco rep. As you can see, a very pinpoint protocol designed for ultra-fast convergence on manually configured links. So we have seen what it is, where it's placed, and even the configuration on a Metro Ethernet switch. I hope this has been informative for you, and I'd like to thank you for viewing.